Thank you everyone for coming. I'm Matt, and I'm going to talk about the myth of the monocluster. So, as a quick intro, I'm a PM at Google. I'm not going to talk about anything Google-related, because I'm sure you're all probably tired of that at this point. And I'm still pretty unsure whether I should keep writing conference talks. It's always like a last-minute thing. So, this talk is about the monocluster. So, the monocluster is the idea that you have this one big Kubernetes cluster in your organization, right? You might have dev and staging, but you have this one big production cluster. You had a data center, you have a cluster. It's this like ideal world to sort of deploy into. It's controlled. You know the surface of it. That's great. But this talks about reducing the blast radius of your Kubernetes clusters. It's about understanding the failure modes, and it's also the considerations as you scale Kubernetes at an organization level. So, what are these myths that I'm talking about of this like monocluster? It's that one large cluster makes sense. It's like, isn't that what like Google does with Borg and sort of similar sort of cluster management tools? Is it that managing more masters is bad? Is it that centralized controls great? And that's often true. Is it the fact that it's Kubernetes? You just keep scaling this thing, right? 50 nodes, 5,000 nodes, 50,000 nodes, right? That like inevitably Kubernetes will come along with us and we'll have this huge cluster that just everyone deploys to and it's all shared. We don't want teams running their own stuff. And if you have a big cluster, it's easier to maximize resource usage, right? You can bin pack more stuff. You don't have sort of like wasted baseline deployments sitting around that are idling some of the day. You can control all of that sort of auto-scaling with a single cluster much more easily. So, the problems are, building a single company-wide cluster sounds like a good idea. And the biggest problem with that is like teams work at different paces. They all have different risk tolerances. And what you end up doing is with a single monocluster, you end up operating at the pace of your slowest team. So if your slowest team is your core billing team, your user database team, like if you're an e-commerce site, maybe it's your .com front ends, right? They're going to be slow. They're not going to deploy every week. They're not going to want to be on the latest version of Kubernetes just because you want these features. They don't want those features, right? They're going to wear the risk. When you have this big cluster, you kind of start to ossify, and you start to not upgrade. You start to not think about security. Security patches often involve upgrades. They often involve, potential sort of rolling restarts. You start to add all this risk because you're too scared to sort of actually do anything. It actually is almost in the inverse, right? At some point, you're like, I'm going to de-risk by having one big cluster. It's all fully controlled. Everyone's on the same version of Kubernetes. Great for debugging. Everyone has the same experience. And then at some point, the table turns and you say, actually, wait, all of these teams are beholden to like one particular team. This probably reminds you a lot of like microservices in general, right? There's a very somewhat sort of pattern here and sort of paradigm. We had monolithic applications. We started to break them down because we're all sort of, deploying them once a year in the bad old days, or realistically, once a month or so. And it was scary, and like only one person knew how to sort of deploy. And we kept slowing down. So what are the challenges with, a not monocluster design, right? It's kind of avoiding following the org chart. It's, with a monocluster, it's also like how big is too big. With individual clusters, it's how small is too small. Like, do you have, in a large organization, do you just have 100 clusters of 10 nodes each or something like that? And, stuff like multi-cluster orchestration, which is pretty nascent and pretty hard to do. So let's talk a little bit about sort of double back on the monocluster part, right? Which is, I've said it's bad, but like I haven't proved to you that it's bad. Some of you probably had experience with this before, but you're like, what are the ways that it can fail? And are those ways bad enough to do something else about, right? Do you maybe just sort of like push through it, solve those problems? Are they even reasonably solvable problems either tomorrow or next year? Obviously, there's a lot changing with Kubernetes in general, and a lot of that's happening sort of this week. But what are these failure modes that we want to get away from? So, think about it in these sort of three ways. What components, scale with the cluster, and where their failure counts actually like scale proportionally or even worse with the cluster size and shape, right? So what components fail when the cluster's, or likely to fail when the cluster's 50 nodes and, 2,000 pods versus 500 nodes, and order of magnitude more pods, so on and so forth, right? What are the things that start to get worse and worse and have a much larger loss radius just inside the cluster, let alone the cluster actually impacting the organization? What's the impact of those failures on your services, right? Is it like complete failure? Is it just a partial failure? Is it some kind of degradation of service, and can you manage around that? That might be okay, right? You might just say, hey, I'm okay with having one cluster. If failure is like a partial degradation, I can sort of work around it, right? And that sort of speaks to, can I avoid it? Can we sort of avoid those problems in general? So there's a few parts. DNS always fails. It's nearly always the bottleneck, right? It is doubly so if you're actually syncing back cluster DNS to some other kind of DNS that you need to sort of rely on, whether it's your cloud provider, whether it's on-prem, right? You have some infrastructure somewhere else that like services outside Kubernetes. If most of us probably aren't 100% Kubernetes everywhere, unless you're sort of very new or very into it, right? So there's more failure points there as well. If the cluster DNS fails or the controller that's syncing DNS fails, you've lost even more. You've lost all connectivity in and out. And when DNS performance sort of actually starts to take a hit, right, that impacts like all your service-to-service lookups as well, right? And for the most part, TTLs in Kubernetes are typically pretty short to deal with auto-scaling challenges as well, right? You want those names to be reasonably fresh so that other services know where to go. So if you see, if you've ever seen sort of the Kubernetes failure stories on GitHub, which I highly recommend, and there's a great list of a long number of like how it's failed for many organizations in many different ways, you notice that I think there's about 30 or so, 17 of them feature DNS, right? DNS comes up a lot as a failure mode, right? And again, without DNS, what are you going to do in your cluster? How are services supposed to communicate? You're probably trying to get away from hard coding IPs, which is one of the reasons you probably moved to Kubernetes, to have more of this sort of dynamism. What else? So the API server and, by extension, sort of like etcd, right? That's your control plane, right? With DNS, that's the core part of the control plane. Scaling your masters vertically only gets you so far, right? You can keep scaling them up, but inevitably the actual API server binary itself is potentially going to have issues, right? It's still not actually, reducing the blast radius. You've just actually packed more on, right? 32 cores, 128 cores, as much RAM as you want to throw at it, right? You can keep scaling these up, and we live in a world of, scalable virtual machines, but that's only going to take you so far. It can also be really hard to fix problems once you actually start having API server issues. So you can't roll back, or you can't scale out if things are under load. You say, hey, I'm just going to scale a little bit more to sort of like deal with the load issue and actually debug why these services are overloaded individually later, right? If you can't actually tell the cluster to do those things, that starts to become pretty hard to get through, and you start to have these compounding problems where API server contention or DNS server contention makes it hard for services to talk to each other, so they respond in kind by potentially increasing API server load as they try to scale up or like get status updates, so on and so forth, and you potentially bring down or make the cluster inaccessible. So, of course, I think you're not allowed to do a talk here without some kind of like Kelsey Hightower quote tweet, right? But it's a really key part is your control plane should be sort of scoped to the smallest failure domain you can afford. And that is, can you afford the whole business failing because all the services you're running are on the same cluster? Probably not. Could you afford your customer-facing APIs or .com failing because they're all on the same cluster as well? Probably not as well, right? This is like really not a place you want to be. I think failure is inevitable. We should assume that at some point, even with sort of all the magic and sort of orchestration that Kubernetes provides, that things will fail, and we should have a plan to sort of deal with that failure, right? So figuring out what the control plane is around that. Is it the same CI pipeline? Maybe you can deal without that. You have a break class for deploying manually if you really have to, right? If your CI servers are down, you have a thing that like can let you make fixes manually in a absolute worst case, right? That's probably manageable, right? But is it the same set of masters? Is it the same set of underlying hardware, right? The whole point of us like having these sort of orchestration platforms is to get away from the hardware and be able to sort of abstract that. But if we're coming back to these singular control planes, we've just manufactured another form of sort of failure. And the other part of this is you think about how do other workloads, right? Noisy neighbor is still a problem in Kubernetes as well, right? Again, one big cluster, all of these things contending. You can have the smallest nodes, you can have these huge nodes with tons of cores and RAM, and there's plenty of things that Kubernetes is not correct for, right? If you've ever written like a pod manifest, right, you can have CPU and sort of RAM, like memory limits and sort of requests, right? But what about network? What about disk I/O, like IOPS? Like you can't reasonably define those through Kubernetes directly for the most part, right? And those things can totally destroy your cluster, right? They can completely blow up workloads. It's very easy. In fact, I've seen many folks do this, and I'm speaking from experience. They define everything with, resource limits, and it's great, and it's going to be awesome. And they have this really like disk I/O heavy application, and it completely saturates the network and the VM as well. And none of it actually works, right? It never actually uses all that CPU and RAM. It never gets actually rescheduled anywhere else because it's totally within its limits. But they've tried to pack as much as possible onto this single cluster, and they've blown everything up, right? At some point, network interfaces and disks will only scale so much. Cool. So the way to sort of think about this is like multi-tenancy, and that's really the core of having a monocluster, is you want this big multi-tenant sort of system that deals with all your business. It has a lot of dimensions, right? You're sort of dealing with, again, you're dealing with memory resources, you're dealing with CPU, you're dealing with network, you're dealing with other users on the system who maybe don't have your best interest in mind, right? You might work at the same company, and like you're not out to get each other, right? But like they have their things to get done, you have your things to get done. You might not be talking to each other about this kind of stuff. And when you have a large cluster, right, it's not like individually are you all managing or thinking about how much load am I putting on the API server, or is like, am I making enough, like, am I making too many DNS queries to sort of like reach outward and make requests outside of the cluster? Like when you're all together and you're all sort of sharing the system, right, that isolation is not always there. And Kubernetes only provides so much isolation. Like namespaces don't give you really what you want in terms of actual underlying workload isolation. Even stuff like gvisor and Kata containers and Firecracker, right, they'll isolate the actual workload running in the container from ideally breaking out and actually doing things on the host, right? But that workload can still interfere with everything else, right? So, think about this another way, right? I think the challenge is that when you have a big monocluster, you're trying to make clusters general purpose, right? You're trying to say, hey, I can build a thing that everyone in my business can use, that every developer is going to love, right? It's sort of like CTO brain maybe. And it's going to solve a lot of our problems, right? We all have this nice, consistent sort of deployment target. And it's actually really hard to do that, because how are you supposed to know what every team wants up front on a system, particularly as you're migrating Kubernetes, which is still the case for most organizations? How do you know what those requirements really are if no one's ever deployed to this before, right? If no one's actually run this truly in production before, right? You'll never gather all those requirements in full up front. And trying to pile everybody into the same system and say, oh, web front-end team, you're here, billing team, you're here, I'm going to put some stateful services on this cluster, right? They all have very different requirements. And you end up with this just sort of massive scope creep. You'll probably never build a cluster that actually meets any of like even half those requirements. And you're exposing yourself to more and more and more failure modes. So we should avoid a single production cluster. I think I've probably made that opinion pretty clear at this point, right? But what do we do next? What's the sort of alternative to this, right? What's the, in many ways, like the knee-jerk reaction to having one big cluster? Is that like everyone gets a cluster? So we have one big cluster. We break it down into a series of clusters, right? Like one of these is again like our billing. One of these is a bunch of backend services. Some of these may be sort of internal like authentication systems. We've like broken out these sort of failure domains. Maybe some of these services are running across multiple clusters. So this looks like okay. Like this is a moderate amount. And this is kind of a good mood. Like everyone gets a cluster. They can do what they want. They can sort of manage their own requirements. They can install whatever they want on it. They can keep up with the latest stuff. If like, hey, I want this thing in like in 1.16. Right? I want these features. I can upgrade my cluster with my team. We get agreement. I don't have to get the whole org to buy in. That sounds pretty good. But we kind of like put some structure to these a little bit more. And what we kind of end up with is like a bit of an org chart where every team has a cluster, and that's probably not actually what we want. There's actually a name for this, and it's called like Conway's Law, right? And it's the idea that we sort of produce the designs that actually like mirror the size or the shape of our organization. And again, this goes back to the whole sort of what we've probably seen from microservices, where that was actually in some ways pretty good, right? Not always being bound to other teams, helped a lot of folks move at their own sort of pace, right? We use, and most of us use sort of API contracts to sort of at least agree upon some sensible boundaries between how we sort of interact, right? That's pretty good. I don't think that is as good in the Kubernetes case, where every team is now running a cluster, right? Because are these teams development teams, or are they Kubernetes operations teams? They're probably development teams, and Kubernetes is just a tool to get the job done. So, cluster team, common law, like kind of go hand in hand, but it's really not what you want. So, I've talked about this a little bit before. Why many clusters? They work at different paces. You have the handful of clusters to manage flexibility, so you can deploy different things at different clusters. You can have different versions. It's way easier to canary properly at scale, right? Teams can replicate their clusters. They can do things at their own pace. And again, you don't have to keep moving at the pace of your most risk-averse team. That is not what we want. We want the teams that need to be able to sort of experiment. We need the teams that can maybe tolerate an hour of downtime if they really screw up, right? Maybe there's like a batch job team or an ML team that's like, hey, look, if we lose some progress, that sucks, but I can tolerate an hour of downtime if we have to roll back and rebuild our cluster from scratch. That's not so bad. Your team that's managing the authentication services for your customers, not so much, right? That's probably a serious outage that's going to page a whole bunch of folks and keep you up at night. You really don't want that, right? So you end up operating at their pace instead. So the problem is that instead of one pet, now you just have many pets. Every team treats these clusters like their little baby. It's like their favorite thing in the world. They have customized it intensely for their own things, and they've ignored everything that they don't have to think about, they don't care about, right? Oh, I don't need like security policies. I don't need like admission controls. We know everybody in the team. It's fine, right? But now they start to resistant to change themselves, right? So we've come back all the way through, and we've said one big cluster is bad because no one wants to change it. Now we have, say, 50 clusters, and no one wants to change their cluster. The teams are now platform teams, and realistically, right, it's actually it's not the way you want to operate this sort of business, right? You end up with a whole bunch of, and really I think security issues that sort of comes down to. So we end up like this pet infrastructure where, again, everyone's just looking out for what they want. But we also know multi-cluster is hard, right? If anyone here has tried to operate in a multi-cluster environment, where you actually have services truly across multiple clusters, right, with stuff like sort of MCI, so like multi-cluster ingress, or deploying things to multiple clusters and keeping them in check and making sure that if they scale on this cluster, that they're also scaling proportionally on the cluster over here. That's actually still pretty hard. And the cloud providers don't make that a ton easier today. Most of these sort of existing Kubernetes distros don't make that a ton easier. There's a lot of tooling out there, but it's still not super mature, right? Like the idea of like true multi-cluster federation is still really growing. So there's hard things. We talked a little bit about security. Version drift is real. So version drift of the cluster itself, of the masters, of all the components they're running. So if you have any admission controllers, any other kind of custom controllers, any kind of operators, stuff like gatekeeper, all those things start to have version drift. That starts to become a real problem, right? Security patches, again, that's also an issue. It's like, who's watching out on the mailing list? How does the security team actually manage, like by proxy, all of these clusters and make sure that teams upgrade, right? Now they have to go and convince 50 distinct teams to go and prioritize this patch, right? And in many orgs, even with the best security teams, that can be really hard. They all have different deployment strategies because they've customized how they generate their manifests and what CI/CD platform they might be using. You might have, Circle CI or like TeamCity internally, right? But everyone's like deploying to their cluster in a slightly different way because it just works for them. Your SRE and ops teams versus dev teams, there becomes a huge mess there. It's like, well, they don't really want to own this because they didn't build it. It's all custom, and it's truly impossible to troubleshoot, right? You have a dev that moves from team A to team B. It's like moving to a different company in the worst case, right? You have this cluster that is different version, different software, different deployment, different risks. All of it is very, very different, right? That actually becomes really hard. And in most companies, you're not just working every day for a single team. You're doing a lot of cross-functional work. You're helping out other folks in neighboring teams to solve their problems, right? If you're an ops like your SRE team, it's even worse because you get paged and you're like, okay, great, I think we've seen this before and it's this problem. You get a brand new cluster you've never seen before, and there's another like 49 of them out there in the company that you haven't touched it because they just haven't broken or you haven't even realized because you haven't actually hooked up any kind of monitoring, right? Again, how do you kind of enforce that kind of like standardized platform when you've got so many clusters? So where do we go from here? Like, one cluster bad, 50 clusters also bad. Like, is there a middle ground? Is there some kind of like, formula we can figure out and say, hey, like, X many people in our company or X many teams means, Y many clusters? Not really, but I think, what you can think about in terms of criteria will help you get there. So this goes back to, I really love saying like the whole like, it's cattle, not pets thing. You should treat those clusters like you can throw them away, right? And that doesn't apply in the monocluster case because that's all you've got. It doesn't apply when every team has their own cluster, right? It applies when you truly think about clusters as a throwaway thing, right? You should be able to throw them away. If that cluster gets deleted and you can't bring it back up in a reasonable amount of time, and a reasonable amount of time depends on your own sort of SLIs and SLOs, right? That might change, right? But you might say, look, my goal is that I can bring a cluster up from scratch in an hour in precisely the same state as it was when I deleted it or destroyed the whole thing, right? That's good. So use stuff like the cluster API or cloud providers toolkits to like define a base cluster config that is shared, right? And that's where your platform team is going to have the most influence, right? They're going to define the baseline controllers, the baseline versions. You might even have, a moderate amount of sort of different channels that is like super stable, deal with a little bit of risk, super cutting edge, deal with a lot of risk, right? But that's much better than probably having 6 different versions of Kubernetes all across your business, let alone all the other sort of dependencies. Use stuff like, Gatekeeper as part of like a policy agent and CI tooling to enforce consistent policies across teams and then like audit that drift, right? Even if you can't maybe enforce everything because teams like, I really want to break glass on this and do something a little different, at least catch that drift and figure out what it is, right? And that also makes troubleshooting easy because you can understand what was different from those policies and look at those things first, right? Stuff like Gatekeeper is really good for that. And again, I talked about this, it's still pretty hard, but definitely try to take a multi-cluster ingress approach to de-risk your like customer world-facing services. So again, you can't multi-cluster everything easily without a lot of pain. That's kind of the dream state to have this like lovely federation of clusters, and you can deploy things to like 5 clusters, and it just all scales magically together. That's not probably going to happen, but at least anytime soon. But for your really core stuff, put the effort in to do that, right? Put that effort into like have multiple control planes. It may be even okay if it doesn't sort of perfectly autoscale on both clusters or downscale on both clusters at the same time, right? You might just say, look, I really want to focus on reducing the blast radius here. I want to focus on having, a case where if this cluster fails, I have some capacity over here, right? It's different hardware, it's a different network. I'm trying to sort of reduce all of these shared points of failure along the way. Right, because that control plane, again, is not just even Kubernetes, it's everything around it that it interacts with. So, again, what is the right number of clusters? Is it, are we talking 1 per team? No. Are we talking, 10 of them? That's kind of hard to assess. So the way I think about it, I think that really the core criteria I want to get down to is map out these risk domains. The idea that you have teams that completely risk averse, and these are the old teams that start to slow the old monolithic cluster design down, right, where you start to sort of move at their pace and not everybody else's pace. What services are most likely to impact others? For a lot of services that are super high IOPS, use the network a lot, isolate those. Isolate those from your critical services. Don't share them on the same clusters even, right? Yes, you could probably put them on different nodes with affinities and taints and sort of go that way too. But, that's only like one dimension of this sort of like, again, this multi-tenancy, is break them out. Put them somewhere else where they can fail and impact only themselves and not other services in your business, particularly, again, the ones in that really sort of critical risk domain. And, last but not least, it's all good to sort of talk about all this and say, like, we can all architect this in like a vacuum, but, what's your actual real dollar budget? Like, how much time do you want to go and spend to make this sort of the most fault-tolerant, reduced blast radius system in the world, right? At some point, you need to draw a line and say, look, this is actually what we think is good enough. There'll probably be a subsequent failure where things go wrong. We go, okay, we're going to do a little bit more, right? And there's always like a learning process. You'll never get it right the first time. But certainly trying to engineer this like perfect, completely fault-tolerant system from day one is also not going to work. So draw a line and say, look, again, Core services, these things have to be multi-cluster. I need to be able to sort of deal with these, deal with an outage of a complete data center, deal with an outage of like a complete cluster or a serious bug in this patch release of Kubernetes, right? Think about all those things that could go wrong just by having a single cluster and all of its dependencies, and have something that's a little different. So who should do this, right? I strongly believe a dedicated platform team should run your clusters, right? A team that has experience in actually doing this, whose job it is to secure the cluster, upgrade the cluster, maintain the components. The job is to not write important business logic for the company, right? That's what a lot of the devs want to be doing, right? They have another job that's not maintaining clusters. And again, what ends up happening is that when you give people this sort of joint responsibility, again, in this sort of like every team has a cluster, you get this incredible tension of like, I have all these tickets in my backlog and I have the annoying PMs and everybody's like saying, we're gonna ship this stuff. And less people are probably saying, oh, we need to make sure we upgrade to the latest version of Kubernetes because it fixes these problems, or we need to make sure that we shore up our DNS configurations, so on and so forth, right? If a team is trying to sort of become a platform team and actually write functional code for the company, those things really don't work. And I've seen that fail a lot. One particular case was a team wanted to sort of write their own operator. They were a data team. They'd never touched cloud or Kubernetes before. And they spent months like focused on actually kind of rebuilding a platform and nothing on their core infrastructure. And it took forever. They learned Go along the way because they learned the operator framework. Like, it's a great learning experience for sure, but at the end of the day, right, like, they still aren't experts in this. They still have this like now extremely bespoke cluster that's like their pet that they're scared to sort of do anything with, let alone upgrade, right? Because like they haven't even tackled that before, so that's even harder. Having core platform teams manage this is just much, much better. And again, those platform teams get to see and generalize all of the problems that folks have, right? Oh, teams are having a hard time because they're using like the raw APIs, which we really don't want to expose to sort of like most development teams. They can shim those, write tooling that sort of understands those cases. They can also look at, again, they see a problem on, even if the ops team's managing, say, 20 clusters, 50 clusters, they can see problems over here and map them to problems over there. When people own their own clusters, that doesn't always happen, right? How many sort of dev teams are going to write a fully fledged post-mortem for their individual cluster failure and share it with the rest of the organization every time? But again, that goes back to the fact that they have this sort of tension between their actual day job and managing this cluster, which is really just the means to an end, right? They had this individual cluster because they didn't want a monolith. And now, again, they're treating it like a pet. So again, we're at KubeCon, I think we can probably be pretty honest, like there's a lot of growth for Kubernetes to do, and there's a lot of growth for a lot of folks to sort of figure it out, right? And again, just throwing it at sort of individual developers doesn't always work. So just sort of put a wrap on this. What are the takeaways? How do we've said like the myth of the monocluster, we don't want this single cluster design, but how do we actually like get to a world where that's not the case, right? How do we convince others in our organizations that this single like whole of the world cluster design is really not what we want? The idea is you should start small. So focus on teams, particularly if you're sort of moving into Kubernetes early. Start small. Focus on a team that has like a clear use case that like really works well in Kubernetes, right? It's like a stateless application. It's something that needs, a significant amount of auto scaling or is like a very bursty workload. Find something that like really fits to the paradigm of Kubernetes where it is right now. And as you start grabbing more people and sort of increasing the sphere of how many teams and workloads you're pulling into this, document the shortcuts too. Document every shortcut you take. You say, hey, actually, we took a shortcut because for this particular workload, it didn't really matter enough to do it like the correct way. But take those notes so you can come back to them and realize like those things that you need to go and fix later, right? Again, understand you'll never capture the requirements up front. That makes it just truly impossible. The idea that, again, you can have this whole of company cluster that just suits everyone's workload perfectly doesn't exist. You'll never finish writing the like PID for this or the functional requirements. Be mindful of the blast radius. So every time you're adding new components or you're adding things in a shared cluster, think about if that fails, what else does it take out? Think about if it fails, if the whole cluster fails, like what is the impact of everything else beyond that, right? Again, in many cases, having some kind of degradation where you have services split across different clusters is probably better than nothing. And at the end of the day, Kubernetes is a platform, right? Let your platform teams run it. I think it's still important that developer teams actually understand how it works, right? I think if anyone's actually looked through all of the scheduler predicates for Kubernetes and the growing number of predicates, right? Understanding how your actual pods and your workloads get moved around and rescheduled and scaled is increasingly complex, but also pretty important to understand, right? Because you want to understand how to actually program and build an application within those boundaries. But you don't have to know every piece of the platform, right? If you, at that point, you're not actually thinking about the other things you want to be doing. Cool. So I kept it pretty quick. It's at the end of the day. So thank you all for coming, and I hope you enjoy the rest of KubeCon.